All right, in the last lesson, we focused on side, 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 and side angle side. So now in this one, we're going to focus on angle, side, angle, angle, side, angle, and angle, angle, side. So I need to click on there real quick. Okay, so in this one, we focus on angle, side, angle, and angle, angle, side. So angle, angle, side, what that one states is that if you have two angles, and now you need to have an included side of one triangle. If they are congruent to two angles and the included side of another triangle, then the two triangles are congruent to each other. So the included side, remember, if these are my angles, then it's the side that lands between them. So if these are my angles, it has to be the side that lands between them. So the included sides are congruent. Therefore, I can state that triangle ABC is congruent to triangle DEF. Make sure you state them in the correct order. A matches up with D, the included side. B matches up with E, so therefore C would match up with F. So make sure you state that in the correct order for your congruency statement. So the included side here, again, your included side needs to fall between the angles. So your included side would be segment GI, segment HI, and then on our last one, it would be segment GH. Here we could state the included side. So for Y and E, for angle Y and angle E, it would be this segment that lands between them. So it would be segment YE. Between those two angles is segment ES, and between those two angles is segment SY. Now you need to have the two angles and the included side. That's the only way that you can prove triangles congruent by side, angle, side. But now the angle, angle, side theorem. So for that one, if two angles and the non-included side of one triangle are congruent to two angles and the non-included side of the other triangle, then the two triangles are congruent. So if I have angle A and angle B, the non-included side would either be BC or it would be AC. Both of those are non-included. So angle, angle, side, or you could say angle, angle, and then the side. Now because I have angle, angle, side on the first triangle, I have to have angle, angle, side on the second triangle in order to be able to state for a fact that these two triangles are congruent to each other. So triangle ABC is congruent to triangle DEF. Now be careful with this one. So there is no such thing as a side-side angle postulate. If I try to construct a side angle, and I try to construct on another triangle side angle, it's actually possible to construct two different triangles if that's all the information you have. So you can never prove triangles are congruent by using side angle. Don't ever try to use side angle. It does not work. It's possible to construct two different triangles out of that. Also, there's no such thing as angle, angle, angle. And that's because I can dilate the triangle. When I dilate it, it becomes larger. So therefore, they're not congruent. So you can never, ever use angle, angle, angle to try to prove triangles are congruent. So which ones can we use so far? So far, we've done side, angle, side, angle, side, and angle, angle, side. So name that postulate. For this one, we have a side and then an included angle and then a side. side included angle, and then side. So side, angle, side. Over here we have angle, included side, and then angle, angle, included side, and angle. So angle, side, angle. For this one comes out to side, side, angle. Now, an easy way to remember that you cannot use side, side, angle is if you reverse the letters. Take a look at what happens when you reverse the letters. You obviously spell something inappropriate, so therefore that's kind of a hint or an indicator that you can't ever use side, side, angle when you're working with triangles to try to prove them congruent. So that one's not possible. And then the last one, side, side, side. Here we have angle, angle, angle. And whenever you have angle, 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 you can dilate that triangle to make it larger. So angle, angle, angle does not work. Angle, side, angle, we have an included side this time. On our next one, we have an included angle, so we have side, angle, side. And now on this one, we would have side, side, angle. So again, if you think about it, side, side, angle, if I reverse the letters, it spells something inappropriate. So we know that that will not work. We cannot do that. Indicate the additional information needed. So if I want angle, side, angle, I have a side, I have the included angle, but we're looking for an included side on this one. So that means that I would actually need this angle up here because the side is what's included. So I would need to know that angle B, that the measurement of angle B is congruent to the measurement of angle D, or the measurement of angle B is equal to the measurement of angle D. Whenever I use measurements, I need to use the equal sign. But if I just said angle B, then I can use the congruent symbol. So I would need to know this little bit of information in order to be able to state angle, side, angle. For side, angle, side, in that situation, all I would need to know is that this segment down here is congruent to this segment over here. And then for angle, angle, side, I would need to know that angle A down on the bottom left is congruent to angle F. And that would give me the correct order, angle, angle, side. All right, and that completes this section on the next two. Excuse me, we still haven't talked about the fifth one. Come on, get back to the beginning. Let's just get out of here. So we still haven't quite talked about that fifth one, the hypotenuse leg. So this one was just angle, side, angle, and angle, angle, side. But we still need to discuss this hypotenuse leg.